Hello, thank you for being with me. Want to help us go over this Isotopia worksheet for those who were absent on Friday. Hopefully you've got this PDF queued up. Again, we're learning here about different types of isotopes. So let's look at this graph to start. Zoom out a little bit. You can see along the bottom, it's showing us protons going up. And then on our y-axis going up, different numbers of neutrons. And this is a zoomed in version of the graph that you'll see on page 3 of this document that looks a little bigger. Hopefully you remember that the number of protons assigns identity to each element. If you have 1 proton, you are hydrogen anywhere in the universe. If you have 2, you are helium. But we'll see that neutrons, we can have a different number of neutrons for different elements, and that's what makes an isotope. Same number of protons, but a different number of neutrons. So this first question asks, how many isotopes does hydrogen have? Hopefully you see. We've got 1 proton here, and we've got 1, 2, 3 boxes on that line with 1 proton. So we're seeing there are 1, 2, 3 different isotopes of hydrogen. Some of them have 0 neutrons, some have 1, some have 2. So how many isotopes does hydrogen have? 3. How do they differ? They have a different number of neutrons. Good. Let's keep going. Number 2 asks, if you had a sample of beryllium, would all the atoms be identical? And what about a sample of lithium? And I do not expect you to have this memorized. I don't have periodic table memorized. Asks about beryllium though. I would go to my periodic table and I would look for the B. I see here, element number 4 is beryllium. Let's see. With 4 protons, do we have multiple isotopes? No. There's 1 box on 4 protons. So it looks like no matter what, 4 protons, only 1 isotope. How about for lithium? Atomic number 3. Again, you'll have these to check. 3 protons. If I go up, ooh, 1, 2. 2 isotopes for lithium. Some lithium will have 4 neutrons. Some lithium will have 3 neutrons. Does that feel good? I hope so. Please let me know if not. All right, keeping us cruising. These questions, part 2, we're going to use this big, gnarly, beautiful graph. And again, this is the same graph where if we look at the axes, we're seeing proton, just number of protons going up for each different element. And then going up here on our y-axis, the count of neutrons. It is the same as the graph on the first page, where for each number of protons, if I have many boxes on that line, those are all different isotopes because they have a different number of neutrons. Please let me know if it doesn't make sense. The first question asks about phosphorus. You will need to jump to a periodic table to find out its atomic number is 15. But they're asking us, phosphorus has only 1 naturally occurring isotope. Write its name and symbol. So between your periodic table and this chart, we can write its name and symbol. If you found it on your periodic table, phosphorus, its symbol is P. So for phosphorus, you would just write P. Its atomic number, also the number of protons, is 15. But we're looking at isotope notation. So how many neutrons does phosphorus have for this 1 isotope? We're going to use this chart to tell me. So again, phosphorus, I know it's atomic number 15, so it has 15 protons. I'm going to go down here, and where I see 15 protons, I'm going to just go up and find the isotope, or find a little box. And what I'm seeing is a box right here, above 15. I guess that's 16. So for phosphorus, 16 neutrons, but your mass, how do we calculate mass? It's your protons plus your neutrons. 16 plus 15, 31 is the mass of that phosphorus. You remember our isotope notation is the atomic number here and then the mass, the total mass up here. Okay, so for that first one, 31 and 15 with that P. All right, let's keep going. Number 2, which element has the most isotopes and how many does it have? This involves us reading the chart. Make your best guess. But remember, oh, this is better for you than the kids who are here in class. For each one of these elements, remember, each one of these boxes is an isotope. So if I followed this down and count how many protons, this one has 7 isotopes. Here I see 1, 2, 3, 4. So we're just looking for who has the most. 1, 2, 3, 4, 5, 6. Nope, not you. I'll let you find this one. And just reading who has the most boxes up and down, because that, yeah, for 1 proton. Hopefully you feel okay on that one. I'm losing my mind. All right, 3. Write the isotope name and symbol for the most abundant isotope of nickel. So, hold up. Nickel. They want us to find the most abundant isotope of nickel. On this chart, you look down here, there's the key. And starting to read. The darkest shaded in ones are the most abundant isotopes. So we're looking for the black square wherever nickel is. I go to this periodic table. Metals are in the middle. I see nickel at 28. So I'm going to go down here to 28 protons. Right now. You do you. On this, I can't, 28 is imprecise here. I go to 30 and I go 1, 2 over and I see 1, 2, 3, 4, 5 boxes, 5 isotopes for nickel. Yeah, because we're at 28. 5 isotopes. Down here is the most darkest shaded in one. It's on the line with 30 neutrons. Remember, our isotope notation is the total mass, not just the neutron count. Oh, it's a thinker. Atomic number was 28, so 28 plus 30 will be the mass. So for this one, 58. You told me the atomic number is 28, and then nickel is its symbol. So for the most abundant isotope, we found nickel on the periodic table to find out how many protons. Then we looked at all the isotopes, and again, the darkest shaded in was the most abundant with 30 neutrons. Let me know. Shredden. 4. Do you expect to find an atom with 26 protons and a mass of 52? 26 protons and a mass of 52. Let's see. I'm just going to write this down for me. 26 protons and a mass of 52. 26 protons. You can find out who it is, but it doesn't matter. 26. So I'm going 25 on the line. I'm going 1 over. I see 1, 2, 3, 4 isotopes. A mass of 52. Do you remember? Your mass is your protons plus your neutrons. So my mass minus my protons will give me how many neutrons? What's the question? Oh, 26. So mass of 52. Oh, it's a long day. I'm sorry, loves. 26 protons means we're looking for something with 26 neutrons. Does it exist? All right, so with 26 protons, we want to see if there's 26 neutrons that match up. You see what I see? This is where 26 is. Here's 25. Here's 26. Is there a box right here? No. Do we expect to find an isotope with a mass of 52 and 26 protons? According to this graph, that isotope does not exist. No. Okay? Okay? Sorry, I know you're big. Whoever you are watching this. Let's talk about 5. There's another thinker. We're in the question. Imagine that a chemist is trying to establish whether a piece of rock is from a meteorite that fell from outer space or from Earth. The rock contains more copper 65 than copper 63. What can we conclude? I have to know what's normal on Earth. And we have that isotope graph. So again, this mystery rock has more 65 than 63 copper. See you, copper, you're not expected. Let's look at this beautiful thing. Again, you're not expected to know. I gotta find copper. Copper, my friend Cu. Protons, 29. So I'm going here to find 30, and I go 1 over to 29. So I see the friends that are copper are right there. Do you remember this neutron number is added to our proton to give us the mass? So let's find what are the two isotopes that we're seeing here. Again, for copper, 29, what I'm looking at is I'm right above the line of, so I think it's 36 is one isotope. So it would be 36 plus, look at me looking at it, 29 is the mass of one of these isotopes. You can tell me which one? 36 plus 29. Oh, dudes. I'm not even embarrassed. If I added one to this to make it 30, take one away, that's 65. That's copper 65. That's copper 65. Oh my God, I'm sorry guys. 35, 34. So then the other isotope is 34 neutrons plus 29, and that shows me the mass is 63. What did we need to know? On Earth, what's most common? Looking at this chart. Again, we're on copper, 29. It looks like the lower one, the smaller one, is darker, so the smaller one's more common, right? On Earth, we just found out 63, copper 63 is more common. But you just found this mystery rock, and it has way more copper 65 than 63. I'm going to say on Earth, most of our copper is found in the 63 form. It has degraded into 63. So if you find something that has a different ratio, if it's way more abundant in a rare isotope, that is evidence that it did not come from Earth. You want me to write it down? Probably. What can you conclude? Because the ratio of copper 65 to 63 is different than Earth's normal abundance, that suggests this rock is from outer space. Let me know, bibs, sirs, ma'ams, peoples. All right, where on the periodic table are the majority of radioactive isotopes found? You shouldn't have remembered it, but above element number 84. That's the main jam, I'll let you know. Above 84, radioactive. Which elements have isotopes with equal numbers of protons and neutrons? Woo! Let's go back to that beautiful graph. Oh, look at this marker board. This is good. Equal numbers of protons and neutrons. A 1-to-1 ratio. You see, all of these little boxes are representing isotopes. I didn't acknowledge this big line is showing a 1-to-1 relationship, where for every one proton, if you had one neutron, they would fall on that line. You're seeing most of the atoms don't. So it's asking, pick an element that has a 1-to-1 ratio, find anybody that's on this black line. I see 20 protons, 20 neutrons, somebody's there. I see 10 protons and 10 neutrons, someone's there. Someone, something, some element. Write it down. So yeah, pick a few of those for equal numbers, please. 4 types of general information that you can find from this isotope graph. Real talk, 3 of the ones that jump out to me. What is the graph showing you? It shows you what types of isotopes are most abundant. It shows you how many isotopes per element. It shows you the relationship between the amount of protons and neutrons. Let's see what you come up with. I hope this helps. Please let me know if you have any questions. I want you to feel good. Okay? Thank you.